Crown ethers are basically cyclic ethers. They are cyclic ethers. Okay. The simplest of cyclic ethers is one called epoxyethane. It looks something like this. Something like this. That's the simplest of all cyclic ethers. Okay, so crown ethers are just like multiple of cyclic ethers. So imagine you combine a multiple of this together, it forms a crown ether. Okay, and crown ethers have, unlike normal ethers, they have just one oxygen attached to two alkyl group. But for cyclic ethers and for crown ethers rather, they have multiple oxygen atoms attached to multiple alkyl groups. Okay, so all these diagrams you've seen around, the ones by my right hand side and this ones, they are called crown eaters. So let's talk about the nomenclature of crown eaters. How can you name crown eaters? It's very easy. The first thing you need to do is to count the number of atoms we have in the crown eater. So let's start with this crown eater right over here. So let's count the number of atoms we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we say 12 crown. That's the first thing you do. Count the number of atoms, also the number of atoms we have, and add crown to it. So we have 12 atoms here. So you say 12 crown. Then count the number of oxygens we have. We have oxygen here, 1. We have 2. We have 3, and we have 4. So we call this 12 crown 4. 12 crown 4 ether. Very easy. 12 crown 4 ether. Let's see this other example over here. Okay, that's this example here. Let's name the crown ether. We have 1, 2, as I said, count number of atoms we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we'll call this 18 crown. I think that's clear now. 18 crown. Then count the number of oxygens we have. We have 1, 2, 3, 4, 5, 6. So we call this 18 crown 6. Okay. So 18 crown 6. That is the name of this crown ether. Let's go to some more interesting ones by the right hand side, where we have something like this. It's a kind of a little bit more complex. So let's do it. Let's do this together. Okay. So the first one, let's count again the number of atoms we have. But if you look at this very well, we have other things attached to the crown ether. We have this and we have this. We call this benzene, right? So this is benzene. This is benzene. Okay. So we use a short form for benzene. We use the word benzo. So let us leave that for now. Let us name the crown ether. Okay. So how do we name the crown ether again? We count the number of atoms that forms the crown ether. So we have 1, we have 2, we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we call this 21 crown. Then count the number of oxygen we have. We have 1, 2, 3, 4, 5, 6, 7. So we call this 21 crown 7. So this is 21 crown 7. Now, back to the benzene. And I called it benzo, right? How many benzene group do we have here? We have 2. So in chemistry, we use di for 2. So we say this is benzo 21 crown 7. All right. The next one, you can just add ether. You don't need to, but if you want to add ether, you can just add ether at the back. So that is benzo 21 crown 7 ether. Let's name this other one down here. Let's name this as well. The first thing to do again, let us name the original crown ether. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is 18. Then add crown. So 18 crown. How many oxygen atoms do we have here? We have 1, 2, 3, 4, 5, 6. That will give me 18 crown 6 ether. 18 crown 6 ether. Okay. So but we have two substituents. We have two groups attached here. this and this, and they are both benzene, right? So we use the word benzo. Benzo. So how many benzene groups do we have there? We have two benzene groups. So we say this is dibenzo. So this is dibenzo 18 crown 6 ether. Let's name this one down here. Okay, there's no space down. So let's come over here. All right. So let's name first again. Let us name the crown ether by counting the number of atoms we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so this is 18 crown. Now count the number of oxygens we have. We have 1, 2, 3, 4, 5, 6. So this is 18 crown 6 ether. That is the name of the crown ether. So let's name. We have some things attached to the crown ether. We have something like this. We have this. So let us name this. Obviously, this part here is benzene, and we have two of it. That's dibenzene. So let's add that. So we say di. Instead of saying benzene, we say benzo. So dibenzo 18 crowns is ether. And at the end of the benzene, we have, let me highlight that. Let me highlight that. We have this. So let me bring it out. It's something like this. Okay. So how many carbon atoms we have here? We have one, we have two, we have three, we have four. If I'm to count from the parent, which is this cover line, this is the first carbon and the second carbon. So these two groups here are methyl groups attached to the first carbon. So we call this one. Let me change the color. We call this one dimethyl, since we have two methyl group attached to the first carbon, and since we have two, the longest chain here is two, so that is ethyl. Okay, this is 1 1. So this here is 1 1 dimethyl ethyl, but this name is looking kind of long, so we can call this right up here. We can call this tet butyl. So note that 1 1 dimethyl ethyl is same as saying tet butyl. So how many tet butyl do we have here? We have two. So we can call this di. We call this di tet butyl, since we have two tet butyls attached. So this molecule here, this crown ether here is called ditet butyl dibenzo 18 crown 6 ether. So you can see that different crown ethers have different sizes. This is kind of smaller and this is kind of larger. The thing here is that crown ethers contains ions like your lithium ion, like your sodium ion, and your potassium ion. Looking at the sizes of this ion, you can see the biggest ion here on these three is this. This is the biggest. So the bigger the size of the ion, the bigger the size of the crown ether, which means that I cannot fit in potassium ion in a 12 crown for 12 crown 4 ether because of the size of the crown 4 of the crown ether. Do you understand? But we can fit in potassium ion in a 18 crown 6 ether. So potassium ion will fit perfectly in a 18 crown 6 ether. But for a 12 crown 4 ether, we can't fit in potassium ion due to the size of potassium ion. But we can fit in something smaller. We can fit in lithium. We can fit in lithium ion, if you get the idea. So crown ethers contains ions. They contain ions. So if you look at this now, don't forget that oxygen here we have two lone pairs of electron, which will give it a negative charge, to have a kind of partially negative charge. And fortunately, potassium has a positive charge, so there'll be attraction between each oxygen atom and the potassium ion. Okay, so the negative oxygen atom will be attracted. There will be an attraction to the positively charged um, potassium ion, which keeps the potassium ion in place. So why is it called a crown ether? Because if you look at this clearly, it looks like a crown where the potassium is like where you put your head. So it looks somehow like a crown. So same thing happens here. There'll be an attraction between the oxygen atoms and the lithium ion. Okay, one thing you should note is that for a crown ether, the outer part of a crown ether is non-polar. Okay, is non-polar, which means that don't forget that only non-polar, no crown ethers or ethers generally are good solvents. Okay, So crown ethers, as I said, the outer part of the crown ethers are non-polar. So note that a non-polar solvent can dissolve a non-polar solute. Okay, so the outer part of the crown ether is non-polar. Let's take for example, I have something like I have potassium fluoride ion, potassium fluoride, which will give me K plus and F minus. Okay, if I bring this close to potassium fluoride, the K plus is taken away from potassium fluoride, which leaves F minus um, alone in the solution. Do you understand? So it will give F minus that ability to undergo nucleophilic substitutions in an SN2 mechanism. A crown ether can react now with potassium fluoride, taking away the K plus, okay, then leaving F minus, okay, leaving F minus to be able to undergo SN2 reactions. XN2 reactions. Don't forget that F minus here is a nucleophile.